Our design required that we hang the chimes from the top of the frame, so we needed to drill holes in the chimes to put the string through. We used a formula to figure out the nodes of the chime, so the frequency wouldn't be affected by the holes. One problem with this design was that the chimes would swing when you hit them, so we needed to add a reinforcement layer with rubber bands. So we found the other end of the nodes and we strung the rubber bands through the pipes so that they wouldn't swing when they were hit.
So in our original design, we only had one half of our double gearbox. When we changed the program to slow it down, there wasn't enough torque, so we decided to add the second half of the gearbox to increase the torque. We added these two 3D printed parts because the axles were too slippery for the belts. Adding the 3D printed parts added friction, so we were able to spin the belts.
This part we call the roller. It spins and the screws hit the chimes. The screws are evenly placed around the circumference of the roller because the notes in the song are evenly spaced in time. The roller spins and is connected to the motor from this rubber band, which is wrapped with twine so the rubber band doesn't stretch. The roller is attached with a nail going through this wood block and into a round wooden plug that's inside of the roller.
Alright, so since this project required us to use both the motor and at least one of the solenoids, we decided to add in the 4 solenoids in order to play the intro sequence to the song. Since only one of them is a spring-loaded solenoid, we had to add something to the other 3 in order to make them behave in the same way. So we created springs out of coils of guitar wire to attach to the solenoids. So for the programming for the solenoids, we had to turn them on and off in the right sequence in order to hit the notes. And we figured out the time delay between the notes in the program based on the length of the rests and the speed we wanted to play the song.